Okay, I just want to go ahead and finish up the notes that we didn't get to. I want to re-go over the abstract coefficients just because I feel like I rushed through it and didn't really make it clear what it's all about. And as I was saying, it's about matrix algebra and using matrices to solve systems of equations. So I just want to just run through it again real quick. So in order to solve quadratic equations, we derived the quadratic formula, and we did that by creating a generic quadratic equation, ax squared plus bx plus c equals 0, and then completing the square for that in order to get the quadratic formula. So it was as if we had completed the square for every possible quadratic equation, and so we didn't need to do it anymore. We can just plug the coefficients into that formula. And I was saying, what if we did that for a system of two equations and two unknowns? And if we did that and we set these up this way with these abstract coefficients, which I've given different colors to, we could use elimination to solve for y. So we could multiply the first equation through by negative d and the second equation through by a, and that would make the coefficients on the x's the same except opposite, and that way they would cancel. So for the first equation, we've got negative dax minus dby equals negative dc, and in the second equation, we would have adx plus aey equals af. So if we add those two equations together, we're going to have the x's are going to cancel, and we'd end up with negative dby plus aey, and that would equal af minus dc. And then if we factor out the y on the left side, we can solve for y and get y by itself, and it would be af minus dc over ae minus db. So that would be the formula to find y in this system of two equations and two unknowns. Now you may say, how in the world would why would anybody bother to memorize that? It's ridiculous. But actually, there's a pattern that's easy, makes it easy to memorize it. And that is, if you look at the original equations and you look at the numerator of that fraction, you can see that it is the x coefficient in the first equation times the constant in the second equation, and the x coefficient in the second equation times the constant in the first equation. So it's this x pattern, so af minus dc, and then the denominator of the fraction is the x coefficient times the y coefficient in the second equation, and the x coefficient in the second equation times the y coefficient in the first equation. So it's this cross pattern, and when you're solving for the y, you in your numerator, you're going to have the x coefficients with the constants, and when you're solving for the x, you're going to have the y coefficients times the constants. Anyway, it sounds complex, but whenever we get to matrix algebra, you'll see that it's pretty, it's an easy pattern to memorize, and so it does make sense. Anyway, I just wanted to go over that again so you can see kind of a little bit more clearly what that's all about. So moving on, linear variation. You remember that if y varies directly as x, that is to say, is directly proportional to x, then y equals kx for some constant k. That's what directly proportional means. We've done that. And if y varies indirectly as x, that is to say, inversely or indirectly proportional to x, then y equals k over x for some constant k. So we've done that before, direct and indirect variation. And then if y varies linearly, this is the new thing we haven't done yet with x, then y equals mx plus b for constants m and b. So this is what linear variation is. If y varies linearly as x, then y equals mx plus b for constants m and b. So if we have a problem like this, where it says the total cost varied linearly with the number produced, then we would write the equation C is equal to Nm plus B, where C is the total cost and N is the number produced. So instead of having C times Kn or C times K over N, we have a linear variation. So we have this linear equation like y equals mx plus b. So now we can just continue the way we usually do with variation problems. We can use the information they give us to figure out what m and b have to be, the constants. So it says when 100 were produced, the cost was $700. So we can plug that in. We can plug in $700 for the cost and 100 for the number produced. And then it says 400 were produced when the cost was 2,200. So we can plug that in for the cost being 2,200 and the number produced being 400. So now I have this system of two equations and two unknowns. So I can solve for m and b in these two equations just by using elimination. So if I subtract the two equations, well, I'll multiply the first equation by -1. In other words, this is still subtraction. So negative 700 is equal to negative 100m minus b. And then I'll just rewrite the second equation again. Now, if I add the two equations together, I'm going to get 1500 equals 300m, and the b's cancel out. So therefore, m is going to be 5. So I know my m, and so I can write my linear equation once I find b. So all I have to do to find b is just plug m into one of the equations to find b. So 700 equals 100 times 5 plus b. So that means 200 is equal to b. So I've got my m and I've got my b, and now I can write an equation that gives cost as a function of the number produced. And that would be c equals 5n plus 200. So that's linear variation. All right, now circles and completing the square. We've done this with parabolas. Now we're going to do it with circles. Remember where the equation of a circle comes from. What is a circle? It is a set of all points, x, y, are units from a point C, where r is the radius and c is the center. So a circle is just a set of points that are all equidistant from a point called the center. And so therefore, if we have a circle with radius 3 and center 2, 4, we just use the distance formula to express the set of points. So that that left side of that equation is the distance from any point x, y to the point 2, 4. And we know that distance is supposed to be 3, the radius. And if we square both sides, we get the standard form for the equation of a circle, which in general is x minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center of the circle and r is the radius. Now, if you multiply that equation out, you get the general form of the equation of a circle, which is x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared equals 0. Now, if you see an equation of a circle in that form, it's not easy to tell what the center of the circle is and what the radius is. So when you see an equation of a circle in that general form, you have to complete the square to get it in a form where it's easy to figure out the center and the radius so that you can graph it. So here is an equation of a circle in that general form. And what we're going to do is complete the square to change it to standard form. And then we'll be able to graph the circle. So I'm going to rewrite it, putting in blanks so that I can complete the square. So I'm going to get the x terms together and the y terms together. And I'm going to leave a blank after each one. And then I'm going to move the constant, 21, over to the right side of the equation and put 2 blanks over there so that I can add the same thing to both sides of the equation. So for the x terms, the coefficient on x is 6. Half of 6 is 3. Square it and you get 9. So you're going to add 9 there. And then for the y part, you've got an 8 coefficient on y. So half of 8 is 4. And if you square it, you get 16. So I've added 9 and 16 on the left. So I've got to do the same thing on the right. And now I can rewrite the left side as 2 perfect square binomials. So the first one is going to be x minus 3 quantity squared. And then the second one is going to be y plus 4 quantity squared. And if I add up the right side, that's going to add up to 4. So now I have my circle in standard form, and I can see what the center and the radius are. The center is going to be 3, -4. And the radius is going to be the square root of 4, which is 2. So now I can graph the circle. I can just put the center at 3, -4, and then draw the circle with radius 2. So that is how you would complete the square to find the standard form of the equation of a circle. Now, that one wasn't too hard because the coefficients on x squared and y squared were 1. Sometimes they're not going to be, and you'll have to do division. So let's look at one of those. So given the general form of the equation of a circle, 2x squared plus 2y squared minus x plus y minus 3 equals 0, complete the square to write the standard form of the equation and describe the circle. So for this one, we're going to divide the equation by 2 so that we can get rid of those coefficients on the x squared and the y squared. And those two coefficients will always be the same, because if they're not the same, it's not a circle. So we just divide both sides by 2 and we get this. And then we're going to finish the same way we did the other one. We're going to get our x's together and put a blank. We're going to get our y's together and put a blank. Move the constant to the other side and put blanks over there. So for the x's, the coefficient on x is -1/2. So we are going to divide that by 2, which would be 1/4, and then square it, which is 1/16. Then for the y's, same thing. The coefficient on y is 1/2. We're going to take half of it, which is 1/4, and then square it, which is 1/16. And then since we added 1/16 and 1/16 on the left side, we have to do the same thing on the right side. All right, so now we can rewrite the left side as two perfect square binomials. So the x's are going to be x minus 1/4 quantity squared, and then the y's are going to be y plus 1/4 quantity squared. And if you add up the right side, you're going to get 26/16. And so the center of this circle is going to be 1/4 -1/4, and the radius is going to be the square root of 26/4. And we did not graph it. They didn't ask us to, and I'm glad they didn't, because those numbers are not fun to graph. So that is how you do this completing the square when you have coefficients on your x squared and y squared that are not 1.